describing data, going back to some of the first stuff that we did in the course. So the first thing, we'll take a look at this data on some grades for tests that students took in a U.S. history class, and to create a back-to-back stem and leaf plot. So the first thing we want to make sure, put a title on your graph, or on your, whatever your representation is. So we'll just call this test scores. Since it's going to be back-to-back, we'll go ahead right down the middle. 40s, 50s, 60s, 70s, 80s, 90s, and then there's 100. Don't skip any. And since guys are first, we'll just put the guys on the right side, and we'll go girls on the left. So label your two sides. And then at this point, remember the stems for this particular problem will be the tens, and then the leaves will be the ones digit. So pick through, there's an 86, an 87, 88, 88, and go to 91, 91, 93, 95, 97, and there's 100 on the guy's side. Give it a quick key, so that means a score of 65. That way anyone can read our graph here. And then for the girls, we're just going to have to work it backwards. So there's a score of 68, a score of 70, 72, 74, 74. There are two 78s. Make sure you put all the data in there. Don't skip any. Don't skip repeating values. Every value we have is going to go into this, into our graph here, or into our plot, if you will. And so there's your stem and leaf plot. Make sure we got a good label on it. You label your two sides if it's a back-to-back, and you give a key. All right. Next thing is a 5-number summary. So here, just put your data into the lists, and you're going to do the 1 var stats on list 1 and list 2, or whatever list you put them in. And then so for the guys, once we do that, we should see for the guys 5-number summary. 42 is the min. Q1 is 80. The median is 84. Q3 is 91, and then 100. So again, so this is the minimum, Q1, the median, the third quartile, and then the max. And for girls, if you run the 1 var stat for girls, or if you just count the data, you could also put them in order and count. A little bit more cumbersome and time consuming, but there's your 5-number summary for the girls. All right, and where that's very helpful is if we would like to create back-to-back or side-by-side box plots. I've seen it both ways. So again, first thing, it's a graph, so let's go ahead and put a title. So we'll put U.S. history test scores. And since it's going to be side-by-side or back-to-back, if you will, they're going to be on the same axis. Go ahead, draw that axis in there. Try to get these as close as you can. I realize I'm moving pretty quick, but as you can see, trying to space these out as best as possible and as consistently, and label that axis so a reader can understand what you're looking at. So for the guys, the minimum 42, and we go to 80, 84, 91, and 100. So the box goes from Q1 to Q3. Go ahead and label that box for the guys. And then girls is going from 68. Q1 is 78. There's the median at 85, 90, 95. So again, the box goes from Q1 up to Q3. The median is in the middle of the box, and then the end of your whiskers will be the minimum and maximum. Every so often, you might also see a modified box plot if there's outliers. And if that's the case, your whisker would just stop at the first non-outlier value. All right, so if we're going to determine if there are outliers algebraically, what that is the 1.5 IQR rule. Now, you could also determine if there's outliers based on the number of standard deviations away. If something's more than 2 or 3 standard deviations away, it's also considered an outlier. But if we're asked algebraically, we need to go ahead and do the 1.5 IQR rule. As a reminder, the interquartile range is Q3 minus Q1. And so for guys, that'd be 1.5 times Q3 was 91, Q1 was 80, And so that gives us 16.5. And what you're going to do with that value is you're going to subtract it from Q1. Excuse me. So the lower bound is going to be Q1 minus the 16.5. So in our case, 80 minus 16.5, which is 63.5. And then the upper bound is Q3, 91, plus 16.5, which is 107.5. For our particular data set, we do have one value that's outside of that. So 42 is an outlier below. And there are no outliers above. There was none of the guys scored above a 107.5. So we'll just go ahead and note that. So that's the information for guys. And then for girls, slightly different numbers, this time 1.5. Remember, Q3 for the girls was 90, and Q1 for the girls was 78. So 1.5 times 12 is 18. So for the lower bound, we'll do Q1 minus 18, which is a score of 60. And the lowest girl score is 68, so no outliers below. Q3 plus the 18 is a 108. Highest score was a 95, so no outliers above or below. Next, if we're going to describe the data, that's where we're going to use our SOCs. Remember, that's shape, outliers, center, and spread. So for us, both sets, they're both mound-shaped as opposed to a uniform distribution. They're both mound and single-peaked. You might also call that unimodal. Both seem to be a little bit skewed. I would say that guys, we definitely see, and we'll say guys' scores are skewed, excuse me, guys' scores are skewed left. And then if we'd like to, we could say the girls, they do look like they're sort of skewed, maybe a little bit skewed, and you can definitely see the skewness in the box plot here for the guys, how wide that whisker is. And remember, just this is a good chance to point this out, this is still just 25% of the data. A big whisker doesn't mean more data, it just means it's more spread out. So that gives us a pretty good indicator that the guys is pretty skewed. The girls box plot doesn't look all that out of sorts, if you will. So I might just leave it as is. So next we talk about outliers. We do see that the guys had one outlier. Go ahead and tell what it is. The score of 42, while girls had none. Again, right here, there I am comparing the two, right? We're being asked to compare the two data sets. Next, we go with center. Well, the thing is I've already got a measure of center sitting there. I could go and I could use means, but for me, I'm going to go ahead and use the median since I've already got it in my 5-number summary. So the median score for guys was an 84, which was 1 point lower than the median score for girls. And then I'll just jot it down as well. So there's my center. Now spread, probably the easiest one here. We could talk about a few different measures of spread. We got standard deviation, we got IQR, the interquartile range, or just what I'm going to go with, the overall range, and just say the guys' range of 58 points, which, as a reminder, that's max minus min, 400 minus 52, was much larger than the girls' range of 27. So there's your SOCs. Next up, if we're going to create a histogram, again, we'll go with test scores. And so for this, we need frequencies. And then we're going to break these scores up into some bins. For me, what I'm going to do is I'm going to break them up. Scores from 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, and then 91 to 100. So what we see, the start of each bin will be the start of the bar that we're going to use. And then so 4, 6. I'll count by twos. Let me clean that up just a little bit. So again, for a histogram, you can go up the side here. These are going to be frequencies or counts. You could also put counts. I don't know why this, I apologize for the pen is acting up on me. So frequencies. There we go. There we go. Much better. And I'll count by tens just to move this along. So it's just a matter, since we're going to combine the two sets of data, there was one score, so there's one score in the 40s. There were no scores in the 50s, 4 in the 60s, 9 in the 70s, 18 scores in the 80s, and 11. And again, what I've done, I've combined all the data. And then at this point, you just go ahead. So from 41 to 50, there's 1. None in that particular bin. Then we go to 4, 9, all the way up to 18 for that particular bin, and then 11 in the 90s. So there's your histogram. And what we can do from that is go ahead and create an ogive, since we've already got the frequencies. Right, so 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, and 91 to 100. I've already got these pieces of data from before. What I can go ahead and do is, to create the ogive, we need them into percentages. So again, 41, 51, 61, 71, 81, 90. Go ahead and turn them into percentages. So that's going to be 2%, obviously 0 over 43. So this one is 9%. And again, the total here, just so you can see where that's coming from, I'm just dividing each one by 43. 9 divided by 43, so that's 21%. 18 over 43 was 42%. And then 11 out of 43 is 26%. Now, the thing with an ogive is it's not just percentages, it's going to be percentiles. So in other words, we're going to have to accumulate this as we go. So really what we want the cumulative frequencies. So 2% of people scored below a 50. So one way that we could do this, we go to where 50 would be and just above the axis. None of the people scored below a 41, so that's where you're going to start with 0%. There's only one person that scored below a 60, so below that 61, we're still at 2%. Right? Now all of a sudden, when we get to 70, there's 11% of the people that were below that 71. So we'll make a little bit of a move there. And we add another 21%. So 32% of the people, right? So I'm adding as I go. So I'm adding the next percentage in, plus 0.21. So 32% of the people scored below an 80. Then I'm going to add to that the 42%, puts me at 74%. We're below a 90. And then, sure enough, when I add the next 26%, I'm up to 100. So in other words, if you think about it, right, 100% of the people scored below 100. And 1. So one thing to realize, a slope of 0 like that, there's no data. And then if it's really steeper, That's just where more data is. All right. So, quick rundown of some of the information. Categorical versus quantitative. Remember, quantitative, it makes sense to average. And you could have discrete, something you can count, like number of desks in a room, versus continuous. Continuous would be like people's heights. You could be 6 feet, 6 feet 1, 6 feet 1.5, 6 feet 1 3/4, 6 feet and 3/4. You know, it can go on and on. So we can keep breaking down heights into the smaller and smaller fractions. So there's kind of an infinite number of possibilities. So quantitative, it makes sense to average. Categorical, that'd be more, again, they're into categories, height, weight, um, but you can categorize based on numbers as well, like an area code or your zip code. So quantitative doesn't necessarily mean numbers. The best lens to put that through would be whether or not it makes sense to average. So if we're skewed to the right, just as a quick reminder, that means most of the data is to the left. If you're skewed left, that means most of your data is to the right. Symmetrical would be a nice bell shape. We've dealt with that plenty. Bimodal means we've got a couple of peaks in the data. And then as a quick reminder, uniform data wouldn't have much outside of one long continuous peak. I want to remind you, as you're looking at these graphs and these different types of plots, just pay close attention to the title, the axis, and the units that you're doing. Sometimes a big gap might not be as big as it looks when you look at the actual units being used. So, a couple quick questions. Here's an ogive in use based on the number of ounces consumed per week for these 150 college students. So how many were between 0 and 4? So what we'll do, we'll go to 4 ounces, we'll go up, and that's going to be 20% of the students. Oh, it's 20% of 150 for 30 students. Here there were 40 students that took this test. Here's the score distribution in a stem and leaf plot. So we'd like to find the first quartile. Well, we think about this. The first quartile is going to be the 10th person, because each 10 people will be a quartile, 40 divided by 4. So the 10th person for us, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the 10th person right at a score of 21. So that'll save us some time not having to go into the calculator. A reporter wishes to portray the low approval rating. So most of the people did not like the decision. I'm going to draw a quick sketch of this, which means most of the people are sitting down here, and then a few people up there are going to like it. If he wants to show a lower approval rating, well, the mean and the median are going to be in two different places. Remember, when there's an extreme observation, the mean is going to get pulled up, and the median is going to stay right at the 50% mark. So if this would like to show a low approval rating, the median is going to be the way to go. Next question, a medical researcher wants to conduct something about the weights of these women. So here's a 5-number summary, and what percent of the women are between 110 200 pounds. So 110, remember, is quartile 1, and then this would be the max. So in other words, remember, quartile 1 is 25% of the way, which if we're going from 25% up to the max, which is 100% of the data, that's about 75%. Here's one where in this distribution, the mean is at 58. So here's the X bar, and it's below the median of 76. So what we could expect, if the mean is getting pulled down, that probably means that there's some extreme observation that's pulling the mean down, which would cause this to be skewed to the left. If the mean and median are very close, that tells you that it's a symmetric distribution. Here, because the mean is less than the median, that's a skewed left. And if the mean was greater than the median, kind of like we saw with the approval rating, it'd be skewed right. A couple more questions here. Researcher wants to calculate the average height of these patients. So we got an X bar of 156 and a standard deviation of 5. However, the scale was off by 2, so we need to add 2 centimeters for everybody. Well, that means that the new average height is 158. However, recall that measures of center are not affected by addition and subtraction. After that, they'd like to convert it to meters, so we divide by 100. So that's a very straightforward process. Now, you will divide measures of spread, so only when you add and subtract. Resistant, as a reminder, it's not affected by extreme observations, aka outliers. Well, a mean is definitely affected by an outlier. The range, which is max minus min, that's definitely going to be affected if one of those is really big. Standard deviation, the average distance from the center, well, that's going to be, that's the average distance from the center, from the mean. Well, if there's a really big observation, that's going to be affected. So the correct answer here, the median, is the resistant. And then here's a histogram, and this survey data was collected on the youngest children in households. And which of the following is the median? So what we need to do, we need to figure out how many people were in this. I believe there's 4 in the first bin, 1 in the second bin, 2. I believe there's 5 in this particular bin, 3 in this bin, 8 observations, and then 2. If we add all those up, we have a total of 25, which means the median is going to be somewhere around 12 or 13. So right now, really, it's just a matter of let's add them up as we go. So there are 4 plus another 1. That means there's 5 here, and then we're up to 7 all the way back, 12 from here back. So these bins right here account for 12 of the observations, which means as we move from 12 to 13, we're going to be in this particular bin right here, which is 8 to 10 years old. You can also approach it from the top down, right? We should be 12 or 13 from the top, 12 or 13 from the bottom. And again, here's 10 pieces of data right here, which means 12 and 13 are in that bin right there from 8 to 10 years old. And then the final question on here, if we record, here's some variables that have been recorded, which of these are categorical? In other words, which ones shouldn't you take the average, or it doesn't make sense to take the average? And that'll be D.